R6 rational exponents. These are exponents that are written in a fraction form, or potentially they are negative. So, just jump right into some examples. So you already have the notes. Write each expression without a negative exponent and evaluate if possible. Assume all variables represent non-zero real numbers. So, 12. We've got in parentheses -5 raised to the -2. So a negative exponent means we need to, in the Mr. Cassism, put it where it ain't, make it positive. So we are going to take this entire thing in parentheses and move it to the bottom. So it's going to be 1 over -5 squared. And then -5 being squared is going to be positive 25, so it'll be 1 over 25 for that one. Just something to keep in mind, common mistake. If the negative was outside the parentheses, it would have stayed negative. It wouldn't have gone away. Okay. 16. 4 over 3 raised to the -3. So in a case like this, you can think about this a couple different ways. You can either go ahead and put the -3 exponent on the 4 and on the 3, or you can flip the fraction and make it positive first and then put the 3 on everything. That's what I like to do. I like to go ahead and flip it first. So this is going to become, in parentheses, 3 over 4 raised to the 3. Okay, and it doesn't matter which method you use. If you did the other method of doing 4 to the -3 over 3 to the -3, you are still going to ultimately end up flipping it. So I just like to flip it first and get negatives gone as soon as possible. So then this becomes 3 cubed over 4 cubed. And 3 cubed is 27. 4 cubed is 64. And so you would get out to the same answer either way if you had chosen to go this route instead. Would have worked the same way. Let's see, one with a variable in it, number 22. We've got -b raised to the -4. So in this case, it is, the negative is not like inside of parentheses on the b, so our expression is going to stay negative. I've got a negative exponent here, so I'm going to put it where it ain't, make it positive. So I'm going to move this. I still have the -1, it's staying there, over, move this down, b raised to the +4. Any questions on any of that so far? All right, so the next one say to simplify the expression with write answers without negative exponents, assume all variables represent non-zero real numbers. So 26, got y to the 14 over y to the 10. And so, again, we can kind of think about this a few different ways. We can either think about it as just reducing down, but I would like to have, since it's the same variable top and bottom, I'd like to just reduce it down as much as possible. And so the other thing that we can do is our Mr. Cassism. So if you don't know who that is, that's the guy that does car line outside for us. He was my math teacher, and that's what he said. And so the put it where it ain't, make it positive. The other way we can think about it is put it where it ain't and change the sign. And so we never want to be left with negative exponents. So I'm going to use the smaller power and move it to the one with the higher power. So in this case, I'm going to be moving this y to the 10th up to the top. So this is going to give me y to the 14. I can change the sign to move it up here. So that's going to be minus 10, which is going to reduce down to y to the 4th. I don't know why this isn't staying focused today. A little better. So just like when we add exponents together when we're multiplying, when we're dividing, we subtract exponents. And so they still have to be like the same if they had different bases. If one was a y and one was an x, we couldn't have done that. It only works if they're the same thing. Let's see, one that's a little harder, 32, 15. Now they use s, but I'm going to switch it to an x just because my s's and 5s look pretty similar. Over 5x to the negative 8. So hopefully right away with this, you see that 5 and 15 can reduce. So 5 goes into 15 3 times, so that's going to leave me with a 3. Then I want to, in this case, both exponents are negative, but I don't need to just like go through and switch them and like move the x to the negative 4 to the bottom and move the x to the negative 8 to the top, because I'm still going to have to do some reducing. So what I can do instead is I can move my lowest power. Now remember, with negatives, the lowest is going to actually be the negative 8, and I can add it to the top. So this will then become x to the negative 4 plus 8, which is 3x to the 4th. Let's see. 38. 3p to the negative 4 raised to the 2. So all that was in parentheses. Times p cubed raised to the negative 1. So this one is going to be like normal rules of exponents to start with. Okay, nothing like weird to start with. Still want to kind of follow like PEMDAS, because you might be thinking, well, we have a negative, why don't we go ahead and flip it? You could, but I would rather do it like PEMDAS way first. So inside this parentheses, this 2 is going on both things. Okay, so this is going to be 3 squared, and then p to the negative 4 times 2, because power raised to a power we multiply. So p to the negative 8. Then over here, I have it being raised to that negative 1. So p to the negative 3. So again, before I go through and move stuff to the bottom, since I can combine on top, I want to go ahead and do that, because sometimes by combining on top, you never have to move anything. Doesn't always work out nicely, but sometimes it does. So 3 times 3, we know that to be 9. Then p to the negative 8 times p to the negative 3. We add the exponent, so that's going to be p to the negative 11, which now I see that I still have a negative, so I need to move it to the bottom. So ultimately, I'm going to end up with 9 over p raised to the 11th. Let's see. I hope you like exponents, because that's pretty much all this section is. 42. In parentheses, I've got negative 8xy times y cubed divided by 4x to the 5th, y to the 4th. So initially here, I don't see any negative exponents, so that's always exciting. Nothing that I'm thinking initially I need to move. But I do see some x's on the top and bottom and y's on the top and bottom. So I'm sure I'm going to be doing some reducing. So I want to combine stuff top and bottom, as well as go ahead and cancel that 4 and 8. So 4 goes into -8, well, -2 times. So I know I'm going to have -2 on top. I've only got one x on top, so I'll go ahead and have the x. And then y times y cubed, add the exponents, that's y to the 4th, over. Then we just copy over the bottom, x to the 5th, y to the 4th. So now I want to move the variables to wherever the higher, like I want to move the lower one to the higher one. So in this case, this x is going to move down here to this one. So it's going to move from top to bottom. So I have -2 on top. Then on the bottom, I'm going to have x to the 5 minus 1. And then over here, when they're the same, so y to the 4th is the same top and bottom, you can just treat that like you would if you had a 4 on top and a 4 on the bottom, where you just cancel them out. So I'm just going to cross them out like that. And so then my final answer is going to be -2 over x to the 4th. Let's do one more like this. 46. Got 8y squared raised to the -4 times 8y to the 5th raised to the -2, all over, in parentheses, 8 to the -3, y to the -4 raised, all that raised to the 2. So with all the parentheses and the exponents on the outside of the parentheses and stuff, to start out with, I'm going to want to go ahead and kind of like follow PEMDAS and do the exponents on the outside first and then work my way through. So I'm going to do this -4 on both of these. So it's going to be 8 to the -4. Multiply, or I'm raising a power to a power, so I multiply the exponent, so that's going to be y to the -8. And I'm going to go ahead and keep the parentheses just so I keep the grouping. It won't really end up mattering as long as I know I'm multiplying. So then in the other one, I'm going to have this -2 going to both things, so 8 to the -2, y to the -10. All over. Now I'm just multiplying this 2 on both of those since they both have exponents. So that's going to be 8 to the -6, y to the -8. Following so far on this one. So now individually on top and bottom, I'm going to reduce things down as much as possible. And then I'll move stuff top to bottom, bottom to top, whatever I need to do ultimately. So on top, I'm multiplying so I can add their exponents. So 8 to the -4 plus -2 is going to be 8 to the -6. Y to the -8 and y to the -10, add those together. So y to the -18 over 8 to the -6, y to the -8, because I didn't have to do anything with those. So just like the last one, I had the same thing top and bottom. I have 8 to the -6 on the top and on the bottom. I can just go ahead and cross that out. And when moving exponents, it's tempting to always want to move them to the top. But with this one, we want to move the smallest number to the biggest number. So that's going to be the negative 18. So we're going to be moving this down here. So we're going to add it to negative 8. So this is going to give us 1 over y to the 10. Because this gives us y to the negative 8 plus 18 to get there. All right, so that was a lot of dealing with negative exponents. Any questions on that before we move into more rational exponents to finish up? Okay. So now, just says to evaluate each expression. So if we've got number 48, 121 raised to the 1/2. So anytime we have a rational exponent, okay, an exponent in the form of a fraction, whatever the denominator of that fraction is the root that we're taking of it. So in this case, we are taking the square root of 121, okay? If there was a number up here other than a 1, we would be raising it to that power. So the numerator tells us what power it's getting raised to. The denominator tells us what root is being taken. I would say probably 98% of the time you should do the root first because it'll make your life easier. It's a lot easier to make the number smaller than have to make it bigger, than to make it bigger and then try to make it smaller. But totally up to you when we get to that. But anybody know what the square root of 121 is? 11. Uh, 52. In parentheses, I've got negative 8 over 27 raised to the 1/3. So with this one, we do the same thing. If it was a square root, we would have a problem, or an even root because of the negative inside the radical. You can't have that. But since it's going to be an odd root, won't be an issue. So just like what we did when we had, where was it? Something like number 16 where we had a fraction and then we had a number outside. We put it on both pieces. We're doing the same thing here. So we're going to keep the negative. So then I'm going to have 8 to the 1/3 over 27 to the 1/3. And you don't necessarily have to write out, this step every time. I'm more just doing it so when you go back to look, you have it. And so I'm taking the third root of 8 and the third root of 27. Anybody know what the cube root of 8 is? 2. Yep. So I got the negative still. How about the cube root of 27? 3. Now, if you aren't aware on your calculator, if you hit on the left-hand side, there's a button that says Math. If you hit the Math button and then you can arrow down, there's an option that has something that looks like this. Okay, that would do a cube root for you. Under there, there's also one that looks similar, but looks like this. This allows you to choose any root that you want. So this can be any number. So you could have the 100th root of something if you wanted. So I just like to point that out because One, if you ever need it to check something, it's there, and then also potentially on an ACT, SAT, something like that, could be helpful to know what that is. Anyways. So, moving on to another one. 56. 27 raised to the 4/3. So I'm going to show you what this realistically means, and then I'm going to show you how I would actually go through and solve this problem. So far we've just had the ones that had a root happening there, and they were just being raised to the first power because it was like 1/2 or 1/3. In this case, it's going to be actually being raised to something. So this means the third root of 27, and then raised to the 4th. Is what literally is happening here. Now, some people get super excited and decide, I'm going to do 27 to the 4th first. That's fine, but it's going to make your life a little bit more difficult. So I do the root first. So the cube root of 27, we had just said, was 3. So I can look at this now as 3 raised to the 4th. Anybody know what 3 raised to the 4th is? $81. And so it makes it a lot easier to solve than trying to figure out whatever 27 raised to the 4th was, and then trying to take the cube root of that. Let's see, just a couple more and then we'll be done. 60. Negative 32 raised to the negative 4/5. So initial reaction here might be to go ahead and move it to the bottom so that you have a positive exponent, and you can do that if you want, or we can take the 5th root first and leave the negative exponent, and then we can move it after we've simplified it down a little bit. That's what I personally usually do, but again, it'll give you the same thing either way. So anybody know what the 5th root of negative 32 is? And yes, I realize it's not in the right spot yet. I will move it to the bottom, I promise. See if there's anything that you can multiply times itself 5 times to get to 32. Kind of work the other way. 2. So then this is going to be, now I'm going to rewrite this. Okay, I just did this for a visual here. So this is going to be negative 2 raised to the negative 4. So now I'm going to put it where it ain't, make it positive. So 1 over negative 2 raised to the positive 4 now. And negative 2 raised to the 4th is 16. So 1 over 16. All right, and last one, unless y'all feel like you need to see some more after that. We've got 121 over 100 raised to the negative 3/2. So kind of like what I did with the last one, I'm going to take the root first and then leave the negative 3 power outside. So I'm going to do the square root of 121 and the square root of 100, and then raise that to negative 3. So square root of 121 is and square root of 100. And so then I have this raised to the negative 3. So I can, again, since it's negative outside and I have a fraction, I can just flip it and make it positive. So this is going to be 10 over 11 cubed, or 10 cubed over 11 cubed. If you did not have a calculator, I would accept it if you left the answer like this. If you did, just for the sake of time, I've already multiplied it out. This would be 1,000 over 1,331. Disregard why I boxed that, and I haven't boxed anything else, but any questions? All right, so I'm going to go ahead and give you your problems. Since I know the art field trip is tomorrow and all of that, you'll also have tomorrow in class to work on this. So if you don't finish it today, you can work on it and then do the R7 notes as well. If you haven't done R7 notes and you want to go ahead and do that today instead, that's totally fine. But we'll need those on Monday.
Is that the last review?
Yes, that's the last review section. And so then probably, more than likely, next Wednesday will be a quiz and a test next Friday on the review unit. Subject to change, but that's tentative, so I need to put that up there. So these are your problems, so not too many. If you feel like you need to do more after that, if you're having an issue with something particular, you can go through and pick a few more, but I don't want to give you a million. Pretty repetitive, so.